Hi, welcome to day 3 of sinusoidal applications. Today's notes, we only have a couple of examples to go through. The first one deals with a tsunami, and a tsunami, of course, is a wave. It's a fast-moving ocean wave, and water, of course, goes up and down. That's what they're telling us right here, in equal distance above its normal level. The period they tell us this time is 15 minutes. And then they suppose that our tsunami has an amplitude of 10 meters, and it approaches a pier at Honolulu, where the normal depth is 9 meters. That'll be interesting to see what happens later on. So, of course, they don't tell us to in this question here anywhere, but we're going to go ahead and graph it because we probably will have to come up with a model. So if we go ahead and graph this, we, of course, here's our time, and we graph it. The normal depth of the water, which they tell us is 9 meters, so that's kind of, this what I tell us can be interesting. Here we are at 9 meters. Well, if the amplitude is 10 meters, we can go as high as 19 meters. And we can go as low as -1 meter. Now that's going to be very interesting for us because of our, we're going to have a point where we're going to have no water at the pier. So the 9 meters is also very interesting because that's actually going to be our midline. That's also kind of nice for us. They give us our midline. And if we graph this, I'm going to go ahead and start at the height, at the peak, 15 meters. They don't tell us where to begin, so I'm just going to go at our first time, we're at 19 meters. And then at 15 minutes later, we're at 19 meters again. And of course, somewhere in the middle, at 7.5, we're going to be at our low at -1. And let's complete another cycle. That puts us at 30 minutes. We're going to be at the peak again. And of course, 7.5 minutes later, what is that? 22.5 minutes, we'll be at the low again. So our graph will look something like this. That's what our wave will look like. And Mr. Wernell's the bomb because he is surfing on it, on the wave. He cowabunga, dudes. So there's our wave right here. We can go ahead and get our equation. We're going to use our cosine. Y equals A cosine B T minus C plus D. Get our equation A, B, C, D. D is easy there. They gave us that. That's our midline. That's 9. The amplitude, they give us the amplitude, 10 meters. And they even give us our period, which is 15. And C, now of course C, remember we count the distance from the y-axis to the peak, so I can use the 0, or I can use the 15 meters, it doesn't matter. Keep it simple, make it 0, and then to get C we use a period. 15 equals 2 pi over B, so simplifying it we get B equals 2 pi over 15. And therefore we have our equation. I'll go ahead and write that over here. Y equals A cosine of B 2 pi over 15 T, don't have to put the -0, plus 9. And there's our equation. Alright, next of course you know the drill. All these equations now are going to have to ask us to apply it. So we're going to graph this in our calculator. So we go to y equals, we type in our equation. Whoops, clear out everything, second plus 712. Clear out the memory of your calculator first. And after clearing it out, we type it in. We got 10 cosine, and we just write in our equation, second pi divided by 15, and we go x minus 0. Again, you don't have to put the plus 0 there. And then plus 9. And we graph it, but fix your window. Make sure your window matches. So my x min 0, I might go up to 30. My x min, my y min, I might go from -2 just so I can see it all the way to 20. And we can see our wave. There it is. Whee! Whee! And there it is. Look, the world famous Wernell function graph right before your eyes. And of course, so for part A, they want to say, okay, assuming it varies So that's where we get our equation from. It's periodic. Predict the depth of the water at the following times. And that's easy to do. So we want to find y of 2. So 2 minutes after we started, second calc, value at 2. I hit enter, and it tells me it's going to be 15.691 meters. 4 minutes, we're at 7.955 meters. And at 12 minutes, up to 12.090 minutes. Very easy. Those are just typing in your calculator right there, and that shouldn't take you very long. So if you need to, go ahead and pause it and check those out for yourself. Then it says, according to our model, what will the minimum depth be? Now, if you look at the graph, it looks like it's going to be -1 meters. But remember, this is the bottom of the pier. So when the wave comes in, between here and here, there's going to be no water. You can see the bottom of the pier. So the minimum depth of the water will be 0 feet. Not -1 like our model kind of shows. So be very careful with that. Matter of fact, if you ever seen any video of tsunamis as they come in, you always see like the beaches being cleared. You can see like all the rocks and everything. All right. Between what two times is there no water at the pier? So that's easy. We're just going to take our equation, our 10 cosine 2 pi over 15t plus 9, set that equal to 0. And this, of course, is already in our y1. There's our y2. And we just find the two nearest times. That's easy to do. Remember, go to y equals. Go to y2, type in 0. Graph it. You're not going to see anything because it's just graphing along the bottom there. So go second calc. I want to find the intersections again. Intersect, enter. And I'm going to scroll over. Now notice I'm down here when I'm scrolling to about where I think they meet the first time. I just hit enter. So it gives me 6.423 minutes. 6.243 minutes. And the second one, second calc, intersect, enter, and I'm going to scroll over again. There it is. And I get 8.577 minutes. So 8.577 minutes. And it's between these two times that there will be no water. So between 6.243 and 8.577 minutes, there will be no water at the pier. Alright, the next question is kind of an easy one. It says the wavelength of a wave is the distance from crest to crest in one period. Our tsunami is traveling at 1,200 kilometers per hour. What is its wavelength? So that one's pretty easy to do. Our wave, to get the wavelength, we sometimes call that, if I recall, my physics teacher will be mad at me, lambda. To get wavelength, we're going to take the distance, the speed it's traveling, 1,200 kilometers per hour, and we're going to divide that by its length of time. Okay, and it's traveling, and it's doing 1 every quarter of an hour. So we're dividing that by 1/4 of an hour. So if we divide that by 4, because there's 4 of these in an hour, that's going to give us a wavelength of 300 kilometers. So that's how long that wavelength is. Now it's kind of interesting because if you're on a boat, you won't even notice it. Out at sea, if you have the boat at the harbor, yeah, you'll see it. Alright, our last example is a very simple one. It's a variable star. It talks about a variable star whose brightness just alternately increases and decreases. The most visible of these is called delta Cephei. The time between periods of maximum brightness is about 6 days. The average brightness or magnitude of the star is about 4.0. And its brightness varies from a low of 3.5 to a high of 4.5. Express the brightness as a function of time. Now, they're not really asking us to do anything here, but just write an equation. So we'll just write our equation. There's time, and our y-axis this time will be the brightness. Ta-da! So, ready? Very simple to do. So let's start at day 0. Let's start at the day where it's the brightest. So the brightest it's going to be is 4.5. 6 days later, there's my period. See, like there it is. Its brightness is about 6 days. They're telling us the period of it. So 6 days later, we're back at the 4.5. Now its minimum brightness is at 3.5, and that's going to occur at day 3. Go for one more period, go up to 12 days. And of course, that's going to put us down here at 9 at the low. And if you sketch it again, you see it again. Look at this, the world-famous Warnow function. And I'll autograph this one because it is our last day dealing with these. So to write the equation, we're going to use cosine, y equals a, cosine b, t minus c, plus d. So go a, b, c, d, there we go. Draw in your midline. Remember, that's the line in between your high and your low, and that's going to occur at 4, right? At 4, there's our midline, at 4. So D is 4, but that also gives us our amplitude of 0.5, or a half. And we get B and C pretty easy. Now C is again going to be very easy to do. There's no distance between the y-axis and the peak, so C will stay at 0. You can make it 6, you can make it 12, you can go crazy and make it 18 if you like it. Heck, if you're feeling very brave, make it -6, but keep it simple. Just make it 0. To get the period, there it is. There's our period. And we're told that that's 6 days. So that'll help us get B. 6 equals 2 pi over B. Using a little bit of algebra, and you can verify this if you want, we're going to get pi thirds. So pi over 3. And we get our equation. So, and the final equation with notes is right here. 1/2 cosine B. Again, because we're using 0 for C, you can just leave this as T. You don't even need the parentheses. If you want to, you can. That's fine. Plus 4. Alright, and that, ladies and gentlemen, is our final equation for note. Now we're going to work all day on these tomorrow, get some practice, and a quiz the next day, so make sure you study these, okay? Thank you. Bye-bye.